Hi again, I'm Pierre Roman, and here with me I have Ibarra Ramados. Did I say that right?
Yes, you did.
Okay, and we're here to take you through 5 or so tips to optimize their workload performance on Azure Disks.
Thank you very much for having me, Pierre. I'm Vaibhava, as you introduced. I'm on the Azure Disks team, which is a part of the Azure Storage group. And so I work with a ton of different product capabilities around Azure Disks.
Okay, so tell me one thing, because this is something I've had a lot in terms of comments, where somebody takes a workload on-prem, something like SQL Server or a Postgres database on-prem,
Sure.
and they migrate it to a VM on Azure,
Sure.
and then they realize they're not getting the performance that they expected. What should they do? Like, what's going on there?
This is a great question, and it's a question we get asked all the time. And so let me provide a little bit of background. A ton of Azure users are trying to migrate to Azure, and this is a very key process that we're working with ton of different customers on. And so as part of that, customers look to either do a lift and shift of their applications, which is where they want the application to really run as is, as well as there's customers who want to do a rewrite, refactor of the applications itself. Now, lift and shift is obviously a great first step in terms of getting an entrance into the cloud and getting an exposure to Azure. So as part of doing that, really customers are looking to, as you mentioned, take databases and really sort of some of these tier 1 applications and move them to Azure. Now, as part of that process, some of the common questions we get is, 1, how do I make it work as is? 2, are there small tweaks that I can make, either in the platform or in the application itself to make things work better? And then last is, great, I know you run SQL, but are you good with OSS DBs? Are you good with all the different types of applications that I run on premises?
So it's not just I've got so many IOPS on-prem, I need so many IOPS in the cloud.
IOPS is definitely one of the factors, but performance really has a lot of different attributes associated with it. So let's actually look at a couple of tips, like you mentioned.
Absolutely.
So I have here about 5 tips that are simple and easy to follow, but will give you a great experience as you migrate your workload to Azure. So first up, we offer a wide variety of disks. So everything from standard SSD, premium SSD, to UltraDisk, which is the fastest disk in the public cloud. Now, which disk you choose really very much impacts how your application will behave. Because if you're looking for a dev test workload or a low IOPS workload, you're really looking within the standard family. But then if you're looking at databases, things that are high IO intensive, you are looking at using premium. And if you're looking for sub-millisecond latency or super high IOPS for business critical workloads, you're looking at UltraDisk. And so choosing within those disk types is a really important factor to think through.
Especially dealing with either like dev, test, and prod, because you don't want to pay the ultra price when you're in dev or in test.
Absolutely. And in terms of the interfaces that you interact with, they are all compatible. And so you can definitely do dev test, and then you could basically move that in production to, say, a premium SSD, or even use Ultra.
Okay, so tip 1, choose your disk properly.
Choose your disk type, as well as choose your disk size. Now, depending on the size that you choose, that also impacts the performance. So that's really 2 things: choose your disk type and size. So that's tip number 1.
Okay.
Now, tip number 2 is, and many people don't know this, is that the VM size or the VM type also has a very big impact on how best the disk actually behaves.
Okay.
What I mean by that is every virtual machine actually has a bandwidth and an IOPS limit that is defined at the virtual machine level. Now, you could add on a ton of disks, but if your virtual machine is actually going to, restrict that, then you won't actually see that performance in your application, right? So what you need to do is, as you use your application and as you realize that you need to scale up more throughput, more IOPS, you need to ensure that your virtual machine size also factors that in.
Okay, so number 1, pick your disks size and type properly.
Yep.
Number 2, pick your machine
Yep.
size and type properly.
Yep.
Okay, number 3.
Number 3. Now, this is super unique to Azure.
Okay.
Azure has this capability of exposing what is called as the host cache.
Yep.
And what the host cache is that our underlying Azure hosts are extremely powerful. We're able to expose some of the SSDs from those hosts as a host cache that can be turned on and off as part of the virtual machine.
Okay.
And so when I attach my disk to a virtual machine, I can now say enable read-only cache. And what this does is it enables that host cache automatically for all transactions to that disk.
Okay.
And so if you have a read-intensive workload, when you're looking for really low latency and very high IOPS, always remember to turn on host cache.
Turn it on. Okay.
Absolutely.
Good, and do we know whether or not typically people do that, or?
This is something that we find that not everyone does, and it's something that is almost like our first recommendation when we talk to users.
Yeah.
And so definitely, as you attach the disk, and this is super simple, it's on the portal. You attach your disk, and then there's host cache that's available right there.
Turn it on.
Yeah,
Perfect.
turn it on.
All right, so we've gotten our first, second, and third, so are the host cache. What is our fourth?
Okay, so number 4, and this is very relevant to databases. Now, what happens is when you're looking at a database workload, there are different files that are written to
Yep.
and read from, and they have very different characteristics. So based on your database that you're using, these files are slightly different, but at a very sort of high level, if you have a set of files that require very low latency reads, right, and also require high I/O to them, ensure that you're putting them on a separate disk that is enabled with, say, host cache.
The same as we did with physical servers in the past, where we would separate the spindles for data logs and temp.
Absolutely, absolutely. That's a great comparison. The next piece is with write, you want low latency writes and sub-millisecond writes, then ensure that that's on a separate disk. And in Azure, a great way to get sub-millisecond latency on writes is to use the UltraDisk. UltraDisk is designed and built exactly for that, which is to give you very high IOPS, but at very low latency.
Okay.
And the other piece is your temp files, right? If your temp files are really only doing like sort, order by, you don't really need to actually persist that data, then put it on a local SSD. You're going to get amazing performance by using local SSD.
And you mean local SSD other than the drive D that comes with the standard VM?
Yeah, this is the local SSD on Azure.
But it's not persistent as well.
It's not persistent.
Perfect.
Yep. And so that's tip number 4.
Number 4.
Yep. Ensure that your data is going to the right kind of disks.
The right kind of disk. Okay, so what about 5? Where are we at now?
Okay, so number 5 is, after you enable some of these core platform capabilities, every workload is slightly different. So there's some applications, for example, that will have very low queue depth or queue depth of 1. So for example, MongoDB has a queue depth of 1. And so if you're really trying to get sub-millisecond latency from a MongoDB application, that is a great use case for you to use a highly powerful disk like the UltraDisk.
Okay.
Because you need to map that to the workload. So every workload is different. Ensure that you're using the right capability in the back end to map that workload.
Oh, perfect. Okay, so we've covered our 5 tips. You told me you had a quick demos that you wanted to show us.
Yes, I do have a quick demo.
Okay.
So let's jump into it. So what I have here is I have a MariaDB server that is configured with, as we talked about, the 3 disks.
Yep.
So data, temp, and log are on different disks. They're on premium SSD. And what we're going to do is look at a workload-specific characteristic that could make a simple tweak, but could have a really big
Significant
impact on the performance. So what we're going to do first on the MariaDB server is we're going to basically start IOStat.
Okay.
Right? So this is going to give me the statistics on the disk for every 2 seconds.
Okay.
Right? So here you see there's not much happening here, right? Because it's really just, there's just no I/O happening on this disk. So what we're going to do is we are going to pass in a write-intensive OLTP workload that's going to hit this disk, hit this server, and then in effect the disks with a bunch of I/O.
Okay.
Right, so let's go ahead and do that. So here you see that it's got 64 threads. It's trying to write about 10 million entries.
Okay.
And so what you see here is, okay, this is performing okay. We got some sort of TPS, some QPS here. Okay, so let's look on the server. On the server, what you see is you're getting about 1,700 IOPS on this disk, total with read and write. That's okay. We know that this disk is capable of a lot more. So are we really maximizing it? I'm not quite sure about that, right?
Okay, let's go see.
So I'm going to stop this, and what I'm going to do is I have another window that is for the same server. So what I'm going to do here is I am going to open up the config file. So let's go do that. So here we see the configuration file on the server.
Yep.
And what I notice immediately is that by default, MariaDB sets up fsync or local writes for the application, as well as it has enabled what is called a double write for additional added resiliency for those buffered writes.
Yes. Okay.
Now, we have a highly capable disk, which is a premium disk that is available in the backend. So are we leveraging it to the best degree possible? So let's change this up and do an O-direct, which is going to now write directly to the disks.
Okay.
And what we're going to do is we're going to change the buffered write characteristics to 0, because we don't need that. We're going to get all the durability from that persistent storage. So we save that, exit. Oh, let's not do that.
Restart your service.
Let me check if my changes went through. Give me 1 second. No, let me redo that. We just need to do it twice to really sink in, right? Okay, exit. What I'm going to do now is I am going to restart MariaDB so the changes take an effect. There you go. This takes a couple of seconds. So this is really now restarting the server and taking in that configuration change that we made.
And all we did is change the way the database writes to the disk.
Right. We are directing writes to the disk. And so now what we're doing is this is still running, right, IOStat. What we're going to do is we're going to go back and write the same workload, right? Same workload. And what you see automatically is you're seeing that there is a lot more queries that are actually happening here. It's almost double of what we were seeing, and it is consistent. Like, it's not flip-flopping like before, right? So we're automatically seeing that there's a lot more transactions that's happening, and it's actually able to do a lot more queries. Now, we go back to the server, and the thing that we notice here again is that, again, it's double the read and write IOPS that we were seeing earlier, right? Isn't that great for like a quick change? Yeah, so you can see that like a small change, in effect, can show big gains if you understand the workload and you understand the platform that you're running on, and you can really maximize that.
Okay, that's perfect. So you have sessions that you're going to talk about this later this week, right?
Absolutely. So one thing right before that, one last thing.
One last thing.
One last thing.
It's like a cooking show. No, one last thing.
We are actually introducing this really awesome capability called disk performance bursting.
Oh, okay.
And what disk performance bursting will do is for premium SSD disks, which are between 4 gigabytes, which are our newest sizes, all the way to 512 gigabytes, what we're going to enable you to do is leverage
gigabytes or terabytes?
Gigabytes.
Gigabytes, okay.
What we're going to do is we're going to enable you to maximize the performance on the disk. Okay. Now, if I have an extremely bursty workload, so I'm not really using the disk at all for most of the time, but I really want to burst at like one time a day or every couple of days, what we do now is that we're actually going to enable you to keep all that capability in the form of credits and have it available for you to do a burst when the time comes. And this burst, in many cases, could be up to 30 times the IOPS a disk offers. So in this particular example, what you're seeing is on a P10 disk, I'm able to go from a baseline, which is today, which is 500, to 3,500, which is a huge gain in case I have a bursty workload.
Without having to do anything else to it, not having to scale it out.
You don't have to do anything. We enabled it in the back end, and this is in preview, and so definitely check it out, and we'll see it roll out to additional regions in the coming months.
Okay, so they can sign up for the preview directly into the portal, no problem?
Yeah, absolutely. Reach out to us if you're interested in this at Azure Disks at Microsoft.com.
Okay, perfect. And do you have some sessions this week if somebody wants to learn more about this?
2 quick sessions that I will pop up right here. One is BRK 3283, and the other is BRK 4018, which talks to you about price performance, total cost of ownership, as well as best practices around workloads.
Oh, this is fantastic. So, these are some of the questions that I've been getting a long time, and like people that are migrating workloads and are having these issues. So it's really wonderful for you to let us know about these things, and 5 fairly simple things to address.
Absolutely.
Okay.
Yeah, 5 quick tips, and you'll see a lot better performance.
Perfect. So, hey, thank you very much for being with us.
Thank you for having me.
I hope you have a great end of the week. And thank you for having joined us here on Microsoft Ignite Live. And thank you, and have a great day.